Hello guys, welcome to today's summarized tutorial. I will be taking you on a very interesting topic, kinetic theory of matter. Okay, before we move into kinetic theory of matter, let's look at the meaning of matter. Matter is anything that has mass and occupies space. Okay, at the same time, anytime you hear the word kinetic, it simply means motion, or you see energy of motion. All right, so move to the next, state of matter. Number one, solid. They vibrate in fixed position and have definite shapes and volume. What I mean is because the particles in solid are very closely packed, so they do not move, okay, but they vibrate at a position, and we call this kind of movement vibrational movement. So because they are packed, so they have a definite shape and volume. Example of solid that I mean, cup, plate, box, etc. Now the next, liquid. They have definite volume, but not definite shape. Okay, so they do not have definite shape, but they assume the shape of the container. And they also move, but their movement is moderate. So they move in a flowing manner. So such movement is called translational motion. And the reason why they are able to move is because their particles are not as packed as that of solids. The next, gas. They have neither definite shape nor volume and can expand. All right, what do I mean by this? They don't have any definite shape. Gases, the particles of gases are very far apart, so no definite shape, no definite volume. Okay, and they can expand. They can fill a whole room, just a little gas, and they can be compressed also. All right, and gases moves very fast, randomly on a straight line, colliding with each other and the wall of the container. So this movement, we call it random motion. Just like when you spray, gases in a room, probably your insecticide or whatever gas we're talking about, notice that it will fill up the whole room. Okay, move very fast. Before you know it, everyone in the room is already perceiving it. All right. Then look at this diagram. You can see what I'm talking about. At cold temperature, the particles come very close to each other and becomes a solid. You can see this diagram. The part colored blue, all right, is cold. Then as it becomes hotter, the particles begin to separate, turning into liquid. Hotter and hotter, very hot, it turns to gas. All right. The next, change of state. A given substance can exist as a solid, a liquid, or a gas. Change of state is brought about by the change in temperature. Let's take a look at this diagram. When you lower the temperature, it becomes solid, ice, all right? That's freezing. Then when you increase the temperature of the solid, it changes to liquid, all right? The particles will go further away. Then if you further increase the temperature, it turns to gas. That's water vapor, all right? Then when you decrease temperature, the gas will turn back to what? Liquid, and vice versa. All right, let's move to the next, melting. When a solid melts, particles gain enough kinetic energy to overcome intermolecular forces and transition to a less orderly state, okay, to a less ordered state. What does that mean? When you heat up a solid, it will get to a point where the particles will gain enough energy and separate, all right? So as they're separating, they will overcome certain energy called intermolecular forces, okay? If they're not able to overcome that intermolecular force, the force holding them together as molecules, they would not turn into liquid. So that point when you heat them up and it turn from being a solid to liquid is called melting point. It's a given temperature, right? Examples of melting, ice, you melt turn to what? Liquid. So ice melts into water upon heating. Right, next, freezing. Liquid particles lose kinetic energy upon cooling, leading to a transition from liquid phase to solid phase. Okay, so when you lower the temperature that's cool the liquid, it turns into a solid because all the particles will come very close together. That point when they come close together is called freezing point. Examples of freezing. Water turns to ice upon cooling. The next, sublimation. Solid particles gain enough kinetic energy to transit directly into the gas phase without passing through a liquid phase. Okay, so when a solid turns directly to gas without passing through liquid, we call it sublimation. Many of you know your camphor that you use in toilets and probably in wardrobes for some solid air fresher. When you leave it, it just continue disappearing and getting smaller and smaller. That means it's changing from being a solid to being a what? Gas. All right. Example of sublimation: dry ice. Okay, when you freeze carbon dioxide, it becomes a solid, and carbon dioxide can change directly to gas without passing through liquid. All right, that's an example of sublimation. Like you can see this diagram. This is dry ice. All right. And the next, condensation. Gas particles, all right, lose kinetic energy upon cooling, leading to a transition from gas phase to liquid phase. So when you cool gas particles to a lower temperature, they change from being a gas to being a liquid. All right. Example of condensation: water vapor condensing into liquid water on this cold surface. So when you bring out water from the freezer, you notice that there's some gases, there's some gas that are there. So when you bring it out, it now condenses back to liquid. All right. You can see this diagram. You can see cold water. You can see at the surface of the cup, you see some droplets of water. That is condensation. That's water vapor condensing into liquid. And the next, vaporization. Liquid particles gain enough kinetic energy to overcome intermolecular forces and transition into a gaseous phase. So when a liquid changes directly to gas, okay, the liquid changes to gas at a certain temperature, you call it vaporization or you call it evaporation. Example of vaporization: boiling of water to form water vapor. All right. And the next, phenomena supporting kinetic theory. 1. Diffusion. Diffusion is the movement of particles from an area of higher concentration to an area of lower concentration. Okay. So when the particle is moving from where it is high to where it is low, we call it diffusion. For example, when I spray a perfume, okay, at one corner of the room, that corner of the room that I spray it is my higher concentration because we have a lot of perfumes there. Then it begins to move to other parts where there is no perfume. All right. So that is moving from where it is high to where it is low. So diffusion is the movement of particles from an area of high concentration to an area of lower concentration. All right. The next, osmosis, is the movement of water molecules through a semi-permeable membrane from a region that are in higher concentration to where they are in lower concentration. And what do I mean? When you have a substance now that contains water, the movement of water molecules from where there is higher concentration, okay, to where there is lower concentration through a semi-permeable membrane. Semi-permeable membrane means a membrane that allows water to pass through it partially. All right. Example: boiling of yam. Your yam is full of lumps of sugar, lumps of starch. That is higher concentration, and the water contains little or no amount of starch. So the water will move, okay, from where there is low concentration to where there is what? High concentration. All right. So I said osmosis is the movement of water molecules through a semi-permeable membrane from the region of where they are in higher concentration to the region where they are in lower concentration. So like I said, we have yam and water. We are boiling yam. The yam contains lumps of starch and the water contains little or no starch. So that one that contains little or no starch has high amount of water molecules. So it will move from where there is high water molecule. The water will move from where there is high water molecule to where there is low water molecule. That's inside the yam, there's little or no water. Then in the pot, there's a lot of water. So to move from where there is high water to where there is what? Low water. All right. Next, Brownian motion. Brownian motion refers to the random movement of microscopic particles suspended in a fluid, like pollen grain in water. So that zigzag movement, all right, of microscopic particles, that is small particles, okay, suspended in a fluid, okay, is called Brownian motion. All right. This brings us to the end of today's class. Thank you for following. We started from what matter is. We said matter is electric mass and occupies space. Talked about solid, liquid, and gas. Talked about changes in intensity of matter. We said a solid can change to liquid. That's called melting. Liquid can change to solid. That's called freezing. Liquid can change to gas. That's called evaporation or vaporization. And gas can turn to liquid. That's called condensation. Thank you very much. See you in our next class.